Welcome to the presentation on defining components and modules in high-level design. In this session, we will explore the critical aspects of system architecture, breaking down a system into manageable, scalable components and understanding how they interact to form a robust solution. Let's dive into the world of high-level design. High-level design focuses on structuring the core components of a system and ensuring that each part plays a distinct, scalable role. We start by breaking down large systems into manageable chunks, components, and modules, making it easier to develop, test, and maintain the system in the long term. Now, let's define what components and modules are in HLD. A component is a larger unit within the system responsible for specific functionality like payment processing or user management. A module is a smaller part of a component designed to handle a specific task within the larger functionality. These elements communicate with each other to form a cohesive solution. Let's look at the different types of components that make up a system. We have front-end components that focus on the user interface and user experience. Back-end components handle the business logic, including processes and data manipulation. Database components manage data storage. External services like third-party payment gateways integrate outside services. Security components handle authentication and encryption, while infrastructure components manage deployment and scaling. Finally, analytics components track system performance and user behavior. Front-end components are crucial because they form the interface between the user and the system. They are responsible for the design and usability of the application. Technologies like HTML, CSS, JavaScript, and frameworks like React or Angular are used to build these components. The backend is the backbone of our system, handling the business logic and data processing. This is where things like user authentication, transaction processing, and other critical operations happen. Common technologies for backend components include Node.js, Python, Java, Ruby on Rails. Database components are responsible for managing data, whether it's user information, transactions, or other system related data. Relational databases like MySQL or PostgreSQL are often used for structured data, while NoSQL databases like MongoDB are used for flexible, unstructured data. External service components integrate third-party services into the system. This can include services like payment gateways, Stripe, PayPal, communication APIs, Twilio for SMS, or even cloud services. These components allow the system to scale and leverage features not implemented internally. Security components are designed to protect our system and users. They handle tasks like user authentication, ensuring that only authorized users can access certain features, and encryption, which protects sensitive data during transmission and storage. Technologies like OAuth2, JWT, and SSL/TLS are commonly used in security components. DevOps and infrastructure components focus on deployment, scaling, and maintaining system health. They ensure that the system remains functional as user demand grows. CI/CD pipelines, containerization tools like Docker, and orchestration platforms like Kubernetes are commonly used in this area to automate deployment and ensure reliability. Analytics and monitoring components help track system performance and user behavior. These components collect data about how the system is functioning and provide insights into areas that need improvement. Tools like Google Analytics, Grafana, and the ELK stack are widely used for real-time monitoring and error tracking. When defining components in our system, it's essential to keep several considerations in mind. Modularity ensures that components can evolve independently. Reusability minimizes code duplication. Loose coupling ensures that changes in one component don't affect others. Scalability allows components to grow the system, and clear communication defines how components interact with one another. Let's look at an example of components in a real world system, a typical e commerce platform. The front end handles the product catalog, shipping cart, and checkout process. The backend manages order processing and inventory. The database stores user data and transaction history. External services handle payments, and security ensures data protection and user authentication. DevOps takes care of deployment while analytics monitor the performance of the platform. In conclusion, defining components and modules is vital in high level design to create a modular, scalable, and maintainable system. By proper breaking down a system into well defined components, we ensure that each part can evolve and scale independently, contributing to a robust and efficient architecture. Thank you for your attention. This concludes the presentation on components and modules in high level design. If you have any questions or would like further clarification on any of the topics discussed, feel free to ask now.